Here is a very good question where we are going to take a look at the two concepts that the normal reaction force is never a fixed force and we need to always find it using the forces which are known. And second, we can apply the Newton's second law only when the frame of reference is inertial or non-accelerating frame. Okay, so let's look at the question. The question says that a man of mass m stands in an elevator. Okay, so there's an elevator. Just draw a very small little diagram, and the man of mass m is standing in that elevator. Find the normal force from the elevator floor when the man on the man when the elevator is standing still. Okay, so when the elevator is standing still, its acceleration is zero, right? So the forces which are going to act on the man is first going to be his weight downward and the normal reaction from the elevator upward. And because the acceleration is zero, these two are going to be equal, so n is going to be equal to mg. Okay, so the part A, my answer will be mg. On part 2, the elevator moves up at constant speed v. Okay, so if the elevator is now moving upward with constant speed v, nothing actually changes, right? Because there is no external force. There's no external force acting. So still n will be equal to mg, and the part 2 is also going to be mg, right? Now we have to find in the third case when the elevator accelerates down with an acceleration a, right? So now this is an elevator, and actually it is coming down with an acceleration a. Okay, and this is our earth. Now what's happening here is that now the elevator is sort of accelerating downwards, right? So which means the frame of reference attached to the elevator is no more an inertial frame. Okay, no more an inertial frame. Okay, which means we cannot apply F equal to ma in the elevator frame. All we have to do now is come down to the earth, which is an inertial frame, right? So we have to look from the earth what is happening. So from the earth, this man seems to be accelerating downwards also with an acceleration a, right? Very similar to the elevator because coming along with the elevator. So in that reference frame, what is happening? There is a force which is acting mg downwards, right? And a normal reaction n upwards. But this man is actually accelerating downwards with an acceleration a, right? So now we apply the F equal to ma. It will look like mg minus n is going to be the mass of the man and the acceleration a. So now my normal reaction will go on that side. So this will become mg minus na. That is going to be equal to n, right? So elevator is accelerating down, and my normal reaction now is going to be less than mg. Okay, decreased by ma. So this one will be mg minus ma. Now what happens when the a becomes equal to g? If a is equal to g, what will happen? This will also become mg, and my n will be equal to 0, right? So this will become 0. Now what happens if the a is more than g? If a is more than g, then what will happen? My n will become negative from the direction we identified, right? Which means the normal reaction will be downwards, right? It will feel nothing like that, right? So he will not feel any normal reaction. It appears that it is getting pushed downward, right? So the force which is supposed to be acting onward, it will appear that he's trying to push downwards. He will feel no force and almost will looks like he's weightless. Okay, no force basically.